Example 1. We're going to use linearization to approximate the square root of 51. So up to now, what we've done is we know that the square root of 49 is 7 and the square root of 64 is 8. So we know that the square root of 51 is somewhere between 7 and 8. What we're going to do is we're going to use linear approximation in order to actually evaluate the square root of 51. So I'm going to break this down into a couple steps. This is a really cool process that requires a little bit of calculus, but mostly just algebra. So step 1. We know that the square root of 49 is 7. And that's something we know because 7 times 7 is 49. So we are going to let a equal 49. Step number 2. Write the linearization of f of x equals the square root of x at a equals 49. So this is how we solve linearization. So remember that L of x in general is f of a plus f prime of a times x minus a. So that's the general formula for linearization. So we're going to need a couple things. We're going to need the fact that f of x is equal to the square root of x. So then f of a is equal to the square root of a. Now recall that we let a be 49. So you get f of 49 is equal to the square root of 49, which is 7. So this piece becomes 7. So L of x is equal to 7 plus, now we need to find f prime of a. If f of x is equal to the square root of x, then we know that f prime of x is equal to 1 over 2 times the square root of x. So f prime of 49 then is 1 over 2 times the square root of 49, which becomes 1 over 14. So f prime of a then is 1 over 14 times x minus 49. So our general formula for L of x then is 7 plus 1 over 14 times x minus 49. Now in order to use the linear approximation, all we have to do is find L of 51. So we get 7 plus 1 over 14 times 51 minus 49. Doing a little simplifying with algebra, you get 7 plus 1/7, which works out to be about 7.1.42. And there you go. That's how you evaluate the square root of 51. Now, there is one more step, and the last step is to check. So we want to compare with a calculator. So if we take out our calculator and we find the square root of 51, well, look at that, 7.141. So you get the square root of 51 is equal to 7.141. And based off this, by doing it by hand, we're accurate up to 2 decimal places. So we know how now to evaluate the square root of any number by the process of linearization. This means I can ask you to do this without a calculator, and you would input your answer as a fraction. Or if I gave you a basic calculator, you could truncate it to 3 decimal places. So right now, I want you to try to use linear approximation to evaluate the square root of 20. There is more than one way to do this. Okay, let's work it out together and see if we got it right. So we know that the formula for linearization is Lx is equal to f of a plus f prime of a times x minus a. Now we know a couple things, so let's talk about the square root of 20. We know 20 is close to 25 and 16. Either one will work, but because 20 is closer to 16, let a equal 16. If you use 25, it would also work. So here we go. We have Lx is equal to f of 16 plus f prime of 16 times a x minus 16. So f of x is equal to the square root of x, so f of 16 is equal to 4. F prime of x is 1 over 2 square root of x, so f prime of 16 is 1 over 2 times 4, which is 1 over 8. So we get that 4 plus 1/8 x minus 16. This is the general formula for the linear approximation near the point a equals 20, or x equals 20. So now we just want to do is go ahead and plug in 20. L of 20 is equal to 4 plus 1/8 20 minus 16. 4 plus 1/8 times 4, which is 4 plus 1/2, which equals 4.5. This means that our answer should be about 4.5, and because 16 and 25, the halfway point is about 20, we should be pretty close. So now all we need to do is check our calculator. The square root of 20 is in fact 4.47. So we're super close, everything's fine. And that's how you use linear approximation to evaluate a square root.